Now see, today we are going to start Demux lab. Okay, what is demultiplexer? Demultiplexer is a device which is having one input, many outputs. Okay, it is having one input, many outputs. This one input will be activated with the help of selection lines. Okay, this one input will be activated with the help of selection lines. An input, many outputs. So it will be activated with the help of selection lines. Now in this demultiplexer we are learning about 4:1 or 1:4 demux. Okay, it is 1:4 demux. So for designing the 1:4 demux, what do you have to take? You have to take 4 AND gates as an output. Okay, and you should take 2 NOT gates. Okay, this is like S1, S0, S1 bar, S0 bar. So it will be selecting the outputs according to the Y1, Y2, Y3, Y4. It will be selecting the output according to the selection line. If the selection lines are 0, 0, output Y1 will be activated. 0, 1, Y2 will be activated. 1, 0, Y3 will be activated. 1, 1, Y4 will be activated. So that means if the input is at this selection line, if the input is 0, output Y1 is 0. If the input is 1, output Y1 is 1. And if the input is 1, 0, output Y3 will be input is 0, output is also 0. If it is 1, it is 1. 1, 1 means if the input is 1, 1, that means if the input is 1, 1, that means if input is 0, it is 0. If input is 1, it is 1. Okay, so now whatever input you will give, either 0 or 1, that will be activated according to the selection lines. If selection line is 0, 0, input is 0, Y1 will be on. If selection line is 0, 0, 1, so input is 1, or Y1, Y2 will be 1. If it is 0, Y2 will be 0. If selection line is 1, 0, output is 1, this will be 1. If selection line is 1, 1, output is 1, then this will be 1, 1. Okay, so this is nothing but it depends on the outputs. Okay, it depends on the outputs. If it is 0, 0, output is 0. Selection line, depending upon the selection line only it will be activated. So this is your diagram. 0, 0 means you should connect bar. Input is I. Input is I. Input is I. Input is I. 0, 1 means 0, 1. 1 means you should take this. Then 1, 0 means 1, 0. 0 means bar. 1, 1 means you should take from here 1, then from here 1. So you will get this Y1, Y2, Y3. This is your diagram. If input is 0, output is 0. If input is 1, output is 1. On the selection line 0, 0, 0, 1, 1, 0, 1, 1. Okay. So this is the concept of demultiplexer. It is having one input, 4 outputs. This one input can be either 0 or 1. If it is 0, output is 0. If it is 1, output is 1. But it depends on the selection lines. 0, 0, 0, 1, 1, 0, 1, 1. If selection line is 0, 0, what first output will be activated. If selection line is 1, 0, second output. Selection line is 1, 0, third output. 1, 1 means last output. Fourth output will be activated. Now how this output will be visible? If the input is 0, this will be 0 on this selection. If input is 1, this will be 1. Remaining all will be like waste. Okay, so now we are going to construct the multiplexer technique circuit diagram in detail. Okay, we are going to start the multisim simulator. Okay, in multisim simulator, what we have to do means you have to open the multisim and you have to click on the file. Okay, new file. Okay, new file and blank representation. You have to go to a blank representation. Okay, create. Okay, then as soon as see what is the process of demultiplexer. Now we are going to design demultiplexer circuit diagram. Okay, so for designing the demultiplexer circuit diagram, what you have to do means, for designing the demultiplexer circuit diagram, what you have to do means, here first you can see what is multisim. Multisim is a package where you can design, as you all have seen multisim in your second year also. So you can design the circuit by using a simulator is known as multisim. So this multisim simulator, in this we have to know the concept of demultiplexer. What is demultiplexer? Just now I have explained you. Demultiplexer is a device which is having one input, many outputs. So we are going to design 1:4 demultiplexer. Okay, we are going to design 1:4. One is to 4 demultiplexer. Okay, so here we are taking a options: file, edit, view, place. Place means we can place the components. Okay, now what is the basic components available? You will have a short form also. Here you can see the short form. Okay, short form, short forms also you can see. Okay, here basic. In basic you can see the short forms. So for designing the demultiplexer, what you have to do, first we will see the circuit of the demultiplexer. Okay, then we will go for this. Okay, so we will see the circuit. Okay, first open I am opening the file where you can see the demultiplexer. Okay, this is your demultiplexer diagram. Okay, so what is this diagram indicates? It is having 4 AND gates, because our demultiplexer is how much? 4:1 demultiplexer. So it is having 4 AND gates. Okay, 2 NOT gate for selection lines and 4 keys for the inputs, input and output. 4 keys. This is key and this is NOT gate. And what is this? AND gates. AND gates are 4, 7, 4 LS 11. Okay, AND gate. This is nothing but a AND gate. AND gate, NOT gate, and switches. Okay, AND gate, NOT gate, and switches. So you can see the switches. and these are the outputs means bulbs, okay, where you can indicate the bulbs. Okay, so now I am going to construct this type of circuit. So what is the concept here? Concept is that this is having 4 keys, and here, as you know, these are 3 inputs. Okay, out of that 2 are like selection lines, and this is like NOT gate. Why we need NOT gate? For the selection lines, and directly one is like a input. Okay, so these are 3 input AND gates. That is IC number is 74LS11. Okay, and these are the bulbs which is available in the multisim. Okay, now we will construct this multiplexer, sorry, demultiplexer circuit. Okay, for this, file, new, blank, create. Okay, so now I will create the circuit. How to create the circuit? So how to create the circuit means first you should go for basics, and you have to go for switches. Select the switches. Okay, 1, 2, 3, 4. Okay, then after that you can select the sources. From sources you should see the power supply, DC power supply. Then you can see the ground. Sources, ground. Okay, then we will go for TTL. TTL means AND gate, and NOT gate we will see first. 2 NOT gates. 2 NOT gates means A will come. You should select one. Then B we can select. 2 NOT gates. Then you cancel. Then again you go for TTL, and you go for AND gate. AND gate. So AND gate we need how many? 4. 1, 2, 3, 4. Okay. 4. Okay, then you can select the bulbs. Bulbs means you should go for indicators. See, bulbs also you will be having here yellow, orange, okay, green, so you can select red one. One, two, three, 4. You can select any other bulb also. It is not that you should select that only. You can select orange also, green, here bulb, okay, blue also you can select your wish. Then after selecting, now we have kept everything ready. First you ground the things. So what is the concept here? That it is having switch, it should connect to the switch. We should connect to the switch. Then you connect the switch to here, then you connect here. You should connect the switch. Then you connect this switch to this and this switch. See, 3 switches only we will take. Got 2 selection lines. So 1 will be input. Okay. Now we should connect this all first terminal of AND gates together. And first terminal you should connect and gate. Okay, then you should connect this to this, all first terminals we have connected. Now then you should connect the bulb. Okay, then you should connect the bulbs. Bulb is ready now. Now what is the output here? We should give here 5 volts. 5 volts you should give. Then what is the combination now? If the switch is open, it is like 1. If the switch is closed, it is like 0. Okay, 0 open means 0, 1 close means 1. Okay, now we should give a first selection line is what? Here selection lines will be like 0 0 0 1 0 0 0 1 1 0 1 1. So first selection line will be 0 0 means bar, S0 bar, S1 bar and S1 bar. Bar means you should take the output of NOT gate. This bar means you should take this. So here you will be having a switch S1. S1 bar will means this. So if 0 0 means you should take the output of NOT gate. Okay, 0 0 means you should take the output of NOT gate. And 1 1 means you should take the input from this side. Here means you should take the output of bar output you should take. Okay, S1 and S2 bar. Okay, so you should take the output of this bar. Now S0 bar, S1 bar means this you should give to the input 0 0. Okay, then 0 0 1 0 1. One, 1 0. You can connect here to this line 0. No. 1 0. Then 1 1. And 1. Then now see, now we will run the system. Now we will execute. I am pressing this. Okay, now I am running it. Running means when the input is 0, when the key is 0 0 means input is 0 means output is 0. If this input is 1, so first output will be 1. See, now this is 1, remaining all are 0. Now if this switch is 0 1 means this output will be 1, and if this switch is 1 0 1 0 means this is output. Then next 1 1 1 means this output is high. And if this input is, if input is 0, if input is 0, output is 0. If not, it is 1. Okay, so if input is 1, output is 1. If not, it will be 0. So by this, what concept we have learned? It is like a multiplexer and demultiplexer we have learned. So this is your demultiplexer technique, demultiplexer diagram. Okay, you can see here multiplexer is opposite. 4 inputs, 1 output. Okay, so multiplexer is 4 input, 1 output. So you can see the output here. Demultiplexer circuit it is. So you can change the bulb colors also. And stop simulation means this. So you can find the ICs in this form, in TTL form. You can get the ICs. Here you will get the diodes. Here you will get the basic placements of basics. Okay. Here you can get the sources. So automatically you can place everything. Okay. Now what is the concept we have learned here? That when the selection lines is 0 0, output is input is 0, it will be 0. Output is particular output is 0. If it is 0 1, input is 1, selection line is 1 0, so second output will be high, this output will be high. And if 1 1, this output will be high. So now the selection line is 1 1, selection line is 1 1, so this output is high, remaining all are zeros. Okay, so by this we have learned about the demultiplexer technique. Okay, you can see the diagram here. Okay, you can see the diagram neatly how I have drawn. It is in simulation. Again we stop simulation. Okay, so by this we have completed the demultiplexer diagram. Okay, you can take the pic, screenshot of this pic. These are keys, NOT gate, AND gates. So by this we have completed our demultiplexer diagram. Okay, lab.